This is the review for the Unit 1 test for Honors Chem. Question 1. If it is 32 degrees outside in Celsius, what is the temperature in Kelvin? So you need to remember that Kelvin, which is based on absolute zero, is equal to degrees Celsius plus 273. So 32 plus 273 equals 305. So that'd be answer B. Why do we use Kelvin scale for temperature? Well, we use the scale. The answer here is going to be C. It makes all the temperatures positive, so when we're doing calculations, we don't have to worry about positive and negative numbers altering our calculations. How would you report the measurement of this screw with uncertainty included? Well, it looks like this line right here is on the first tick mark past the 5. So all these numbers agree with the 5, the ones place. And they all agree to the tenths place. So the difference here is whether we need to add any more significant figures, how many should we add, and then that will determine what the uncertainty is. Well, since the measuring tool that we have here goes to the tenth of a centimeter, or the millimeter, we can measure with certainty to the tenths place, which means we always add one extra digit that's uncertain when we're making a measurement. So since we can be certain to the tenths place, we want to add a 0. If we think it's right on the 5.1, we would add 5.10 to indicate that the 0.1 is how far our instrument measures, and we're estimating the 0 in the hundredths place. And so our uncertainty here is plus or minus 1/100th of a centimeter. These top and bottom values only go to the tenths place, and since we can measure to the tenths place, we have to estimate past that. And then choice C actually goes too far because we have no basis for estimating to the the thousandths place. So that would just not be a valid measurement. If you drop a box in the ocean with a mass of 10 grams and a volume of 10 milliliters, will it float? So a couple things you need to remember here. Water has a density of 1 gram per milliliter. So anything with a higher density than 1 will sink. Anything with a lower than 1 density will float. So let's calculate the density, which is the mass divided by the volume. And in this case, that's going to be 12 grams divided by 10 milliliters, or 1.2 grams per milliliter. So if it is higher than 1, it will sink. The question was, will it float? So the answer here is no, it will not float, it will sink. The length of the room is 9.10 meters. Convert to centimeters. Well, we know 9.1 meters, that's our distance. 1 meter is equal to 100 centimeters. So in centimeters, since the units here of meters cancels out, we would have 910 centimeters. And we can keep that decimal point because that was a significant figure in this measurement since it was after the decimal. So we keep it significant by adding the decimal point in our answer here, B. If the room measures 9.1 meters by 9.35 meters by 107 inches, what is its volume in liters? So there's a couple things we need to do here. First, we need to convert the meters into centimeters, because that will give us cubic centimeters as a measure, which is a measure of volume. And then we can convert the cubic centimeters to milliliters and convert the milliliters to liters. So 910 meters, or 9.10 meters times 100 centimeters per meter, which we actually just did, is 910 centimeters. Do that again for 9.35 meters times 100 centimeters per meter. We get 935 centimeters. And then the third one, we actually have to convert 107 inches, and we're told that 1 inch is equal to 2.54 centimeters. So we do that out, and we actually get 271.78 centimeters. Now to find the volume, we multiply those three together. 910 times 935 times 271.78, and that equals 2.31 times 10 to the 8th cubic centimeters. I'm rounding my answer because all of these two numbers in my starting values had three significant figures, so I have to round to three significant figures. The question actually wants the answer in liters, so the first thing I'm going to do is convert this to milliliters. Since cubic centimeters and milliliters are equivalent, I can just change the unit without changing the number. And then I can convert from milliliters to liters by remembering that there are 1,000 milliliters in 1 liter. And then I'm going to divide 2.31 times 10 to the 8th milliliters by 1,000. And my final answer is going to be 2.31 times 10 to the 5th liters. So that's the final answer to this question, which would be answer choice C. Okay, these images represent which of the following in order? Well, the first box is all one type of atom. So that means it's an element, which rules out choice B. The second box is two different types of atoms, but they are not bonded together. They are just mixed together. So that gets rid of answer choice A. The last box is a little bit tricky. It appears to be made of one type of compound and one element. Those are two atoms of the same type bonded together, so that's an element, which would make it a mixture, and that rules out choice C. So the correct answer here is choice D. This is an element, this is a mixture, and this is also a mixture. Which of the following is an intensive property? So you have to remember that intensive means it is part of the substance regardless of how much substance there is. It doesn't change based on adding or taking away some of the substance. So mass, obviously if you add mass to the balance, the mass changes. If you take substance off the balance, the mass changes. That's called an extensive property. So intensive is part of the substance, extensive is something that you measure based on how much stuff there is. So mass changes depending on how much stuff there is, volume changes depending on how much stuff there is, and surface area changes. Density is a property of a substance that does not depend on the amount. So that is an intensive property. Other examples would be the melting or boiling point, the color, things like that. Which of the following is a chemical change? A chemical change is a change that involves producing one or more new substances. So when you go through a chemical change, you don't get your substances back at the end. They are used up to create some sort of new substance. A physical change, on the other hand, is something where you're either changing its state, or you're mixing things together, or breaking things apart without altering the substance itself. Dissolving something in water, like salt, for example, is a physical process. You're making a solution of salt in water. If you take away the water, the salt is still there. Dividing a substance into 3 equal amounts, that's equivalent to tearing a piece of paper into 3 pieces. You're not changing the paper into something else, you're just making 3 pieces of paper. Heating something until it boils, boiling, melting, freezing, those are all physical changes. When you boil water, you get steam, which is still water, it's just water in the vapor or gas form. But if you light something on fire and it burns, you do not get that same substance back at the end. You get different substances, either gases, some combination of gases and particles that make up ash, but you don't get the paper back after it's been burned. Which of the following is a compound? Remember, a compound is 2 or more elements chemically bonded together that cannot be separated physically. Oxygen gas is one element. It's oxygen molecules. Even though there are 2 atoms bonded together, they're both oxygen, so that is still an element. Iron metal, iron's an element. Salt water is a mixture of salt and water, so that's not the choice. Sodium chloride, it kind of gives itself away because you've got the names of 2 different elements in there, sodium and chlorine. In the ionic form, we call it chloride. So sodium chloride would be a compound. Which of these is not a method for separating a mixture? Well, this one kind of gives itself away again. A chemical reaction is not a physical method of separation. Distillation is a separation method that takes advantage of boiling points, so that's a physical property, a physical process. Filtration, again, takes advantage of the physical size of the mixture, filters out bigger particles and lets smaller particles pass through. Chromatography is similar to filtration, except that it doesn't actually trap certain parts of the mixture. It just allows certain parts to pass through more quickly than others, and you can separate the mixture that way. If three boxes with the same mass are dropped into a pool, which is the most likely to float? So we need to figure out what we know about the density of the boxes, which is not that much, but when we're talking about comparison and the question is which is most likely to float, we can make some determinations based on that. If they're all the same mass, remember that density is mass over volume. Variations in the volume will affect the density. So the one with the largest density is certainly not the most likely to float. That would be the least likely to float. Well, the smallest volume with equal mass will have a higher density, which means it's less likely to float. Where the larger volume, right, since that's in the bottom, the denominator, the box with the largest volume will have the lowest density of the boxes with equal mass, right? If the mass is equal, then the biggest volume has the lowest density. Will it actually float? That we can't say because we don't know what the actual densities are compared to water. But if the question is which is most likely to float in this case, it would be the one with the largest volume because that will be the least dense. Which of these would you use to accurately measure the volume? Well, these are all different instruments for measuring volume. Erlenmeyer flask and beakers. This is a graduated cylinder, and this is what's called a volumetric flask. Well, if you're trying to measure the volume of a particular sample, you want the instrument with the most markings, the most grades of measurement, the smallest increments, and generally speaking, in this case, that's going to be the graduated cylinder. Beakers and flasks tend to have bigger measurements on the order of 10, 20, 50, even 100 milliliters at a time. And a volumetric flask, its purpose is to precisely measure a specific quantity of material. So it might be a 1 liter volumetric flask, which means it has a line exactly at 1 liter, so you know very precisely where 1 liter is. But if you're trying to measure something that's not a liter, a volumetric flask is useless because it doesn't have any marks on it other than the 1 liter mark. Okay, so the room is 9.10 meters by 9.35 meters by 107 inches, so this is the same measurements as another problem we had earlier. If the density of air in the room is approximately 1.40 milligrams per milliliter, what is the mass of the air in kilograms? Okay, so we've got a couple of things going on here. First, we need to determine the volume of the room. If we go back to our earlier problem, we had calculated that the volume of this room with these measurements, if we did it in milliliters, was 2.31 times 10 to the 8th milliliters. And then I need to convert that first to grams, or milligrams rather, because the density given is in milligrams. And it says that there are 1.4 milligrams in 1 milliliter. So when I do that out, I get 3.234 times 10 to the 8th milligrams. But the question is, how many kilograms is that? So it's 3.234 times 10 to the 8th milligrams. How many kilograms would that be? So I need to convert milligrams to kilograms. So 3.234 times 10 to the 8th milligrams times, there are 1,000 milligrams in 1 gram, and then there are 1,000 grams in 1 kilogram. So by taking these two different steps, I can convert milligrams to kilograms, even though I don't have a direct conversion between the two. So when I do that out, I end up with 323.4 kilograms, which with significant figures would actually round to 323 kilograms. And the closest answer is approximately, it's very close considering all the math we've done, 324 kilograms, answer choice C. All right, if you measure and calculate the density of 3 samples of iron, you receive, or you calculate measures of 7.94, 7.92, 7.91, and then you're told that the actual accepted value is 6.98. How would you classify your results? Well, they're not really accurate because they're relatively far from the accepted value, so that also answers both. It's not an option. So the question is, are they precise? They are actually fairly precise. Okay, remember, accuracy means you are close to the accepted value, and precision is how well your different trials agree with each other. So accuracy is the closeness of one value to the correct answer, whereas precision is the agreement between all of your measurements. And in this case, they were all fairly close, so you were precise. So answer choice B there. Okay, what is the volume of a 1.90 kilogram sample of copper if copper's density is 8.93 grams per milliliter? So we're trying to find the volume, and we're given the density, so we have to remember that density is mass over volume, which means that volume is mass over density. A couple other things going on here. We've got grams per milliliter as our density. We've got the mass in kilograms, so we're going to have to do a little converting there. And then the answer choices are all in cubic meters, so we're going to have to deal with some conversion there. So the first thing we want to do is figure out how many kilograms per cubic meter there are, as opposed to grams per milliliter. 8.93 grams per 1 milliliter, and then we know that there are 1,000 grams in 1 kilogram, so that takes care of the mass conversion. And then we're going to convert milliliters to cubic meters. So the first conversion is converting milliliters to cubic centimeters, or centimeters times centimeters times centimeters, and that's actually a one-to-one conversion, but I'm just putting it in there to get the units straight. And then I need to convert between centimeters and meters. There are 100 centimeters in a meter. So if I'm going for cubic meters, I need to repeat this 3 times. Okay, and believe it or not, when you do all that out, you end up with 8,930 kilograms per cubic meter. So if I'm converting 1.90 kilograms, and I want to find the volume, I'm actually dividing that by the density of 1 cubic meter is 8.930 kilograms, and I get an answer of 0.0000212 cubic meters, which happens to be answer choice C. Which of the following is a homogeneous mixture made or composed of compounds? Well, the air is a homogeneous mixture, but it is made of compounds and elements like oxygen and argon and nitrogen, among other things. Salt water is the answer here because it's sodium chloride and H2O mixed together. Iron sulfide, iron 2 sulfide is a compound, and ethanol is also a compound.